Hello, my name is Brian. Today we're going to talk about the WEM series electric actuator. The WEM series electric actuator has a TMC3 modulating card in it. We're going to talk about some of the functions and features of it. We use the same card in the 500s all the way up to the 25 900s. On the TMC3 modulating card, there's a series of jumpers and dip switches. There's 7 dip switches, 3 different jumpers. The jumpers control your input signal. So these cards have an input signal that ranges anywhere from a 4 to 20 milliamp, a 0 to 10, a 1 to 5, or they can even do the 0 to 135 ohm for slide wire. So one way of calibrating the TMC3 modulating card is turn dip switch 1 on, which puts it in manual mode, dip switch 6 on, which puts it in auto cal mode. Once in auto calibration mode, you hit the red button, and the actuator will calibrate itself. So right now what it's going to do is it's going to find the mid position. It's going to bounce back and forth 3 to 4 times in the mid. Now after it finds the mid position, then it will travel to the full open or counterclockwise position. Once it reaches that position, it'll pause for about 3 seconds and you'll see the green and amber light flash. That's storing the open position, and then it's going to go to the full closed position. Once it reaches a full closed position, you'll see the red and the amber light flash. That's storing your closed position. And then it will default back to the open position when it's done. Okay, now that it's done, that means the calibration is completed. You turn dip switch 6 and 1 back off. And that's the auto cal function of the TMC3 modulating card on the WEM series actuator. We have the signal generator here that controls it. So if we give it an input signal of 4 milliamps, it will go closed. If you give it 12, it would go to the mid. If you gave it 20, it would go to the full open. So the other way of calibrating this actuator is turn dip switch 1 on, which puts it back in manual mode. And then you can do a manual calibration. So say you're trying to adjust the valve to where your open and closed position. You do not need an input signal on for this. It's best if you don't have the input signal on, and the reason being is sometimes your control room is further away to where you can't adjust your input signal, so the actuator will know where it's at if you don't have the input signal on. So if you drive the actuator closed or to the desired position of where you want it in the clockwise direction, when you achieve that position where you want it, you hit the red button, and again you will see your red and amber flash. Then you go open or counterclockwise. And when you reach that position, then you hit the red button, and you will see your green and amber light flash. That stores that position. That's the way you do the manual calibration of the TMC3 servo card. Okay, now let's talk about some of the other dip switches. With dip switch 3 on, it makes it reverse acting. So now your 4 milliamp input signal is your open position. Your 20 milliamp input signal is now your closed position. So if you turn 3 back off, it goes back to direct acting. If you put dip switch 4 on, it will fail open on loss of input signal. The actuator is going to fail to the counterclockwise or open position. If you have no dip switch on, it will fail clockwise. With both dip switch 4 and 5 on, it will fail in place on loss of input signal. Standard it comes, the actuator fails clockwise or closed unless otherwise specified. At that point, you take your 4 to 20 milliamp signal generator, and you have control of your actuator. The TMC3 also comes standard with a feedback signal. So it is self-powered feedback. You do not have to apply any external power to it to get your feedback signal for it. So on 6 and 7, negative being 6, positive being 7, that's your feedback for your signal. Okay, let's talk about troubleshooting. When trying to set the board, the cam will actually interfere with the limit switch, not allowing the board to go to full position. So when you're doing your adjustments, you want to make sure that your open and closed cams are not tripping. So what needs to happen at this point, we need to loosen the screw here, move the cam back to allow it to actually go to the position as needed. A few of the other things, if for some reason, if the torque on your valve is increased or something gets stuck in the pipeline, there are torque switches down here in the bottom of the actuator. The torque switches, if they're tripping, because there's some sort of obstruction or the torque is increased, then you need to look down here in the bottom right here and see which ones are tripping, and then pull the actuator off and try to troubleshoot to see what's wrong with the valve. One of the other problems that we've come across is the hard stops. If the hard stops are not properly adjusted when the actuator is set up, or if somebody has moved them out into the field, it could cause one of two problems. It could be running up on the hard stops, which would also cause your torque switches to trip, or they could be back too far out of the way and somebody could overcrank it past the gear. The hard stop bolts are two different ways in the troubleshooting area that they can cause you problems. Somebody has either ran them too far in to where it trips the torque switches, or somebody's backed them out to where they are going to over travel the gear inside the actuator. So the proper way to set the bolts would be drive it to the closed position. Once it reaches a closed position, you use an Allen wrench and a regular wrench. You run it in until it stops. You back it out 2.5 turns. And then you tighten the jam nut back down. And that is the proper way to set the bolt so they do not interfere. And the procedure for the open and closed bolts is the exact same. You can visit our website at atcontrols.com for any more information, or just give us a call.